Hello everyone, this is Deepak Joshi and today we are going to learn about MCP's Model Context Protocol, which is the new trend nowadays. What is MCP? MCP is nothing but there are things that you can do with MCP, but what basically a MCP is, you can think of it as a tool. It can provide, it can be a tool, it can be a resource as well. So I will be talking about the tool part of the MCPs, that is tool calling, which is very similar to if you have used LangChain, LangGraph, or any of the agentic library, then you should have heard about tools. What are tools? So LLMs are trained on data, and LLMs are not very much updated about the things which are very recent. So, like for example, weather. LLMs are not aware about what is the weather currently in New Delhi or in Bangalore or in Hyderabad or in Telangana. So how will they get to know and then phrase their responses? In this sense, tools comes into the picture. What are tools? Tools are nothing but functions which can make an API call, which can do some mathematical calculations or other sort of operations like querying a DB or ingesting or getting something out of it or something or anything else. So, like in this particular tutorial, what we are going to do is we are going to create a MCP server which will have some tools which our cursor will be utilizing. All right. So let's get started. To create a server, what you have to do is first you have to initiate your Python environment. You can do that by Python -n vn. Okay. Yeah. It's happening right now. Let's just wait for some few moments till it completes. Yeah, it completes. Now you have to activate your environment. You can do that by /env, and then I have to create requirements.txt. This requirement.txt will contain Ubicon. You can work without it as well. Um, we don't need this in this particular tutorial, so I can get rid of this MCP CLI and MCP. These are the two things that you will be requiring, and then what you have to do is pip install -r because we have to install these dependencies, then only we will be able to create our fast MCP servers and all. Yeah, it's still it's happening. Till then, what we can do is we can come into the quick start and we can go to for server developers. What we are building, la 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 get forecast. Okay, so we are in Python. It says okay, you have to do Python 3.10 or higher. Okay. We are on Windows. You can do this. La la la. No, no need to do that. What we have did is we have activated our environment. They are doing it using UV. That's fine. And then building your server, import packages and setting up the instances. So we add these two at the top of the weather.py. They are creating a weather.py tool. So like what they are doing is we need this MCP server.fast MCP because it is built on top of fast API, I guess. And not I guess, but yeah. So we have to implement this. How fast? Like we can do this. It's not that much of a hard work. What we need to understand over here is fast MCP is built on top of SSE. Uh, fast MCP SSE. Okay, let's read something more about this. Nothing is here. I guess there was something. Yeah, FastMCP handles complex protocol details and server management, letting you focus on building great tools. Okay, why FastMCP? Key features, what's new in V2? Okay, quick start. Okay, okay. There is nothing about server sent events. Okay, let's talk about then server sent events, not fast API. What are server sent events basically? So in server sent events, what happens is a client and a server does a handshake, and then server sends events from server to client. It's sort of like WebSockets, like close to very real-time communication, but not real-time. A server push technology that allows a server to push real-time updates to a web client over a single persistent HTTP connection. There is a header in HTTP 3. There are three types of HTTP. HTTP1, HTTP2, and HTTP3. I guess HTTP3 is built on top of Quick. I'm just throwing whatever I know about all this thing. Quick protocol. I guess it was developed by Google. Yeah, this was the one. QUICK. It's built on top of UDP. So I was reading an article that they have built it on top of UDP. An engineer in Google built this. So it's HTTP3. Like if you know about TCP and UDP, then UDP is some sort of faster, but TCP is some sort of secure. So I will not go into depth of that, but yeah. Server-sent events is a server push technology that allows a server to push real-time updates to a web client over a single persistent HTTP connection. This means the client does not need to constantly request data from the server. Updates are sent automatically. SSE operations in a unidirectional manner with the server sending data to the client, but not the other way around. That means only server can pass in data to the client. That is what SSE means. So what we are going to do over here is let's build a src folder and then have a server.py in it. Yeah, let's do this. What we are going to do is we are going to have that thing imported. What was that? mcp.server.fastmcp. Import fastmcp. Simple. So we have imported this. Do we need anything else? Not at the moment. And then we have to initialize this fast MCP. So what we can do is we can create a, or we can just do MCP is equals to fast MCP, and we can name it as uh, YouTube demo. Simple. That's how you can create your MCP. And for now, I'm just creating this, that if name is equals to this, I will be porting it to mcp.settings dot what's the thing, port, I guess. Let's check the documentation. It says, is it talking about port? uh mcp.run. So it's there are two ways of building it. Yeah, I just have to explain that as well. There are two ways to build MCPs. The first one is you can create packages, pipe pip packages or npx packages or npm packages, and the second way of doing this is you can host it somewhere and then have the access for it. That means you can create your own server, deploy it somewhere, and then cursor or any or cloud or any of the client can access through it. The second one, the server one, will be built on top of ssc only. But there is a drawback of this currently as well, so I can explain you that using Excalator, I guess. Skeleton. Yeah. If I am recording it right, yeah. Because many a times I'm into a demo and then I realize, oh, I forgot to turn on my recording. Yeah. So let's say we have this client. Yeah, we have this client, and that can be our, for example, that can be our cursor. Okay, cursor. Now, there can be a server as well. Okay, there is our server, which is holding a MCP fast API, which is built on top of SSE. That makes sense. That makes a lot of sense to me. Oh, oh, oh. Yeah, yeah. So what will happen each time? Let's say a client sends a request to server, the handshake happens, and then continuously server is sending data to the client. Okay, there is one thing happened, but as we will be productionizing it, like there will be a server and then you will be tweaking the things into the server as well with time, as you think of new tools or the user demands for something else, or there is a bug, you will be deploying this particular server many a times. So what will happen is in those cases, it the connection will broke this particular connection will broke because there will be a deployment for this particular server. So in that case, currently cursor is not able to reinitialize it. That means you have to manually go into cursor and then reset it to do a handshake, and then it will do a handshake, and then again yeah. Then again server will send server sentiments to client. So this is one of the drawback. Yeah, there are ways of resolving this particular issue. One of the way that I am currently thinking of is, but we are not going to implement that particular thing over here. It's just for engineering purposes, So the server will still be there. Okay, no problem. There will be a main server. Now what we'll do is we will have a proxy server. This is called proxy server. The how can I yeah proxy server. Yeah, this will be helpful. How this will be helpful? I'm very bad at Excalibur, honestly. Yeah, this is our proxy server, and then there will be our main server. Uh, Main server. Okay. Yes. Yeah, there will be a main server. Now all the communication will happen from proxy server to our main server. And in that case, we can deploy our main server multiple times, but the connection of client to the proxy server will remain intact. Means this particular block will always be in contact, right? But there will be things that you need to take care of. But because how this MCP works is it initially sends a slash messages. You have to dig deeper into it, right? There was a thing, or is there a thing? Base protocol request, and then it says notifications. No, there is a slash message route that comes into the picture. It's the base protocol. All messages in MCP must follow this specification. The protocol defines three types of messages. Requests are sent from the client to the server or vice versa. Request must include a string integer ID, unique, okay, response is this, notification is this. Okay, so it's the transport layer. MCPs works on STDIO. So this is one of the thing that we can discuss. What is STDIO? Standard input output. That means MCP or a tool which we have will return the things into the terminal, and then terminal's output will be passed into the LLM to utilize that out. Here is this. The client launches an MCP server as a sub process. The server receives JSON RPC messages that we just saw in the messages thing. Here is the request format. And then the server receives this message are delimited by new lines and must not contain embedded new lines. Okay, the server may write UTF-8. Okay, the client must. We can take a look into this particular picture. That here client launches a sub process. Okay, then message exchange happens. Then client writes to stdin and sub process writes to std out, and then it utilizes it because it closes the terminal and sub processes, and then then LLM utilizes the client's std out. Okay, HTTP with SSE. In SSE transport, we serve operates as an independent process that can handle multiple client operations. So this one is for in-peaks packages or the packages thing that we were talking about. Server must validate the origin header. These are the things that are for validation. So this is how it happens. Open SSE connection, the handshake happens, and it exchanges the tools that it has, and it does a HTTP post messages, and then SSE messages events. So the post message obtains the things from the server, like what are the tools, what are the necessary tools over there, and then it receives, and then whenever a call to a tool happens, in that case server responds with the output of that particular tool. Okay, so what we can do over here is we have this port. Let's now set it up as 3005. Okay, that makes sense, that makes complete sense. Now we have to run this. To run this, we are going to use transport as not TCP, as SSE. Okay, that makes sense. Let's create a MCP tool, a MCP tool, uh, yeah, and call it as add add numbers. Simple. It will have A, which will be int, and it will have B, which will be int again, and it will return int. So the better how this MCP tools and things work is you have to write description of the tools that you are utilizing. The better the description, the better LM will be able to figure out what tool to utilize, and then on the basis of that, it can do things. So yeah, add two numbers together. Simple. Here is our first MCP server, which contains a simple tool add A and B. Simple. Now, how we can utilize this is you just have to open your terminal, go write Python src and then server.py. I guess this should be sufficient. Then go into settings, go into settings. Yeah, just give me a second. Yeah, go into cursor and then go into full settings here and then go to MCP. There will be nothing. Now, why there will be nothing? Because you have to write a mcp.json, because you have to let your client or the cursor, because here the client is cursor, you have to let your cursor know that, oh, there is a MCP server. So how you are going to do that is you have to do a dot cursor and then you have to create a mcp.json. That will look something like this. Um, that will look something like this. We will be creating a dgit basically to perform all the git operation. That's why the mcp server name is dgit, and then don't use this particular URL. It can be this one. Yeah, this is fine. Okay, that makes sense. Now if you go to cursor settings, there will be this dgit project managed. Now if I refresh this, or if I enable this and refresh this, there is a tool that is add numbers. All right. So now if I go to my chat window and always do have the agent mode selected, and I'll pass in, could you please add 7 and 8 9, and it should be able to pick my dgit tool add number. I will help you those yeah, it was able to pick my add number, and it knew that okay, this particular tool requires two parameters that are a and b, and then I'll click on run tools. It will yield 16. My tool has returned 16. Now LLM will process the output, and the sentence is coming from LLM. Okay, the sum of 7 and 9 is 16. So in this case, LLM does nothing. It called the tool, got the output, and then it what it did what it simply return shows the output in a natural language. Simple. Now what I'm going to just do over here is I'm going to create open my new terminal and do a git init. Simple. I just want to check git status. So there is git status, because we are going to create some tools. I'll just comment this out. This is not our main thing to implement right now. We will be implementing some tools. Okay, just to wipe git over here. Now what we will do is we will create a new mcp tool that will be not this, that will be define git status. Okay, and it will return us the status. Yeah, get the status of the current repository. And what we'll do is we'll have a try catch block enabled, and it will do result equals to, so we need a sub process to for running git commands. What we will do from sub process import checkout. Yeah, that's fine. Or what you can do is you just can do imports of process. That will be helpful as well. I will be just implementing one tool to help you guys out, and then you can figure it out by yourself. Okay, so we'll do sub process dot run and get status, capture content true and text equals to true, and then if result dot return code comes out to be 0, that means return result dot std out, and else return the error. Simple. So here is our get status tool. Let's uh, rerun our server. It should be automatically. Oh, I'm so sorry. Yeah, processing request of time. Yeah, yeah, yeah. Yeah. Yeah, you remember in the initial, in the starting of the video, I was telling you about a problem in Excalitor, that whenever a deployment happens, the server restarts and the client was not able to figure it out by itself. Here is the problem. I restarted the server. Now you can see type error fetch failed with connection this, because it is not able to, because the handshake has been failed out and our MCP server is still working. So what I need to do is I need to refresh and then it will work again. So it was able to pick it up and do the stuff. Simple. Now what I'll do is I'll just go to this particular thing, and then I'll do a git status. That is git status, or simple. Could you please uh, check the status of the git? Simple. It should be able to. It should be able to. I'll check the, and it picked it up that I have a git status. Oh, because we do not need a parameter in our git status, of course. So that makes sense, and it will come to our subprocesses and then run the git status command on branch master, no commits yet, and it was able to track our files. Yeah, it was able to. There are several untracked files and la la la. So there are multiple tools that you can utilize. You can create another tools. I'm not going to create any tool over here for you. You can do that by yourself. You can create tools like git add, git push, git pull, git checkout, git commit. Okay, these are all the tools that you can create. I can show you all the tools that I have created for this video, though I'm not going to demonstrate all of them. The first one is git checkout. It's for check out a git branch. Okay, the second one is for git pull. The third one is for git commit. If you want to commit something, it is for git push. You can there are optional branches that you can push to that particular branch, or the current branch, or main branch, or master branch. Then there is git status that we just implemented now. These are the things that you can do to implement stuff. I hope I was able to explain what MCP is, and we were able to figure out what tools are and how we can utilize tools. You can utilize tools in multiple places. Would love to hear some of the tools that you guys are creating, and please do let me know. Till then, bye bye, take care. And if you have any questions, feel free to reach out anywhere in the comments or on LinkedIn. Yeah, bye bye.